Hey everybody, it's Mrs. Cat, and we are going to be looking at classification of matter notes. We're going to start with the flow chart, and then we're going to look at some ways that we can identify matter based on particle diagrams. So, like I said, we're going to be using a flow chart, so we're going to start with matter right up here at the top. And we're going to split matter into two separate categories, and those are going to be pure substances and mixtures. Okay, so I'm going to use some different colors here. Let's go pure substances in green and maybe like mixtures in whatever color this is, reddish. And then let's do a little connector here and here. All right, so those are our two options. Each of these are going to be split into two separate categories, but we want to go ahead and define what makes something a pure substance, versus what makes something a mixture. Pure substances, we're going to say, have constant composition, which means that they are made of exactly the same type of particle all the way throughout that sample of matter. Doesn't matter what the physical state is, whether it's solid, liquid, or gas, but it does matter that all the particles in the sample are exactly the same. Mixtures, on the other hand, are going to have variable composition. So they are going to have different types of particles all mixed together. We can take mixtures and we can separate them. Now, we say that they are separated by physical means. And I'll give you some examples of that. An example of a physical type of separation that's really common is a filtration, where you would separate solid particles from liquid. There's an example called a distillation, where you would heat a sample up and the different liquids in the mixture would boil off at different temperatures. We also have something called chromatography. That's an example of a type of physical separation technique that is relatively common in the lab setting. But one of the ways that you can designate a mixture versus a pure substance is the fact that those mixtures can be separated. Pure substances can be separated based on the type of substance that they are, but that's a completely different process. So let's go ahead and look at those two types of pure substances. Right? Those two types are elements and compounds. And actually, I'm going to move that over just a little bit more. Elements, compounds. And let's see here. I'm going to be consistent with my color coding here. Let's go green around those two. Okay. So, pure substances, elements, or compounds. Okay. Let's define these first, and then again, we can see the relationship between the two. So elements, we're going to say, are the smallest division of matter, and these cannot be broken down. Okay, you can't get any smaller than that type of particle. Compounds, on the other hand, are going to be chemical combinations of two or more elements. Now, this means that there's some sort of chemical change that has happened to put those two or more elements together into that compound. Now, that's where we get this connection between the two. We can separate compounds through a chemical process to turn them back into elements. Okay, so we're going to say can separate chemically. Okay, that takes care of our pure substances. Like I said, both main subtypes of matter are going to be split into two different types. We've got two types of mixtures that we'll look at now. Okay, I'm going to give myself a little bit more room. Those two types of mixtures are homogeneous and heterogeneous. And then again, let's keep with color coding. If you're like me and that color coding helps, okay, that might be something you want to do. If not, then the basic structure of this without the color coding is still going to be good enough for you. Okay, so homogeneous or homogeneous mixtures are uniform, which means they're going to look the same all the way throughout. Okay, let me give you a couple examples. Of things that are considered to be homogeneous mixtures. One great example is salt water, which obviously is going to be a mixture of salt and water. Once the salt dissolves in the water, the sample is going to look the same all the way from top to bottom. Another example is milk. I like to use this example. We want to say that this is homogenized milk, which you'll see on the container of the milk that it's been homogenized, which means that all of the fat, proteins, and all of the liquid components have been processed so that they do not separate, which is why the milk's going to look the same all the way from top to bottom. Another final example is going to be a mixture that's homogeneous of two metals, and that's called an alloy. But a good example of this is brass, which is just one of the samples that we use in possibly in the density lab. I'd like you to make a note of the fact that these homogeneous mixtures are also called solutions. We're going to spend an entire unit in semester 2 all on solutions. So this is kind of just our first introduction as to what they are. Okay, looking at heterogeneous mixtures, these are going to be non-uniform in their composition, which means that they look different throughout the sample. Again, I'm going to give you some examples that are going to be helpful. So let's start with sand and water. Since we started with salt and water, let's go with beach themes for our first example. Sand and water, if you mix them together in a jar, for example, you can shake them up and they will mix together, but over time that sand is going to settle to the bottom. And so you're going to end up with sand at the bottom, water at the top. Okay. You could also mix sand and salt. And that's going to be an example of a heterogeneous mixture. Both of those are going to be solids. You mix them together, you're going to have different types of particles mixed throughout. If I took a scoop of the salt sand mixture with my right hand and a scoop with my left hand, there's going to be different numbers of sand particles and salt particles in each hand. It's going to be different throughout. And then, I don't know, one of my favorite examples of a heterogeneous mixture is actually like snack mix or Chex Mix. Because you can really see the individual pieces and parts in that mix overall. And again, kind of same thing with the handfuls. You're going to get a whole different mix of each of those. Just like with everything that we do, we're going to look at this idea of classifying matter into pure substances, mixtures, and then further into elements, compounds, homogeneous, heterogeneous, also at the particle level. So let's take a look at this image here, which is going to show some classifications of our different types of particles and how we would name those. And then we can take a look at what we've got in each of these. So these are color coded here. You'll see that our largest rectangle is in purple, and that's going to represent overall generally different types of particles. Okay, if we go further in, we can look and see some of these examples of these different types of pure substances. So I'm going to go here with our atoms. Okay, over here on the left-hand side, we can see that our atoms are going to be individual circles representing individual particles of an element. Okay, elements can also have multiple particles, okay, as we can see in our green box, which is going to encompass elements that are made of one atom or monatomic, as well as elements that are made of multiple atoms, like we see over there on the right-hand side of our green box. Okay, here we have an element that's made of two particles together. Here we have an element that's made of three particles together. We know they are elements because the particles that have been joined chemically are exactly the same. Okay. In the yellow box, we have examples of compounds. Again, a chemical combination of two or more elements, okay, and we can see exactly that that's what we have here. All three of these compounds that are represented here, one with two particles, one with three, one with four, are all showing just the same type of elements, one dark atom, one, or at least one dark atom and at least one light atom, but they're different combinations, so they're going to represent different compounds. Okay, and then finally, we have our orange rectangle, which is going to encompass what we call molecules, and molecules are going to be two or more atoms that are combined chemically together. Okay, these can either be elemental molecules, like we saw in the green box, or they can be compounds that are classified as molecules. Okay, now if we look in each of these little rectangles or these squares, these all represent mixtures, right? The first one that we looked at with the atoms, that is a mixture of two different atoms. Okay, if we get into that larger green rectangle, we're going to see a mixture of multiple types of atoms, both monatomic atoms and multi-atoms, and then, or molecular elements, I guess would be a better way to say that. And then finally, our yellow box with the three different types of compounds is going to show a mixture of compounds. Okay, again, at the particulate level, unless we have more information about the physical state or the way that those substances are mixed, we may not be able to tell whether it is homogeneous or heterogeneous, but you should definitely be able to tell whether you have a pure substance and classify that as either an element or a compound, and that you should be able to classify those particle diagrams as mixtures.